Hey guys, today we're going to talk about radicals. So we did an activity with roots and you'll see it come to life. So what is a radical? So we looked at something like the square root of 36 and we know this is 6. Why? A square root is looking for the number that you multiply by itself to give you 36. Well, 6 times 6 is 36, so that's why the answer is 6. Sometimes we have a cube root. Let's take the cube root of 8. Here we're looking for a number you multiply 3 times to get 8. That number is 2. So the cube root of 8 is 2. Sometimes we don't have a perfect square or perfect cube as we call them, but we can simplify the expression we have. So we start by factoring our number, which I'll do really quick. You guys did this in the last module. And we're going to write all of these numbers under the square root. So I have 2 times 2 times 2 times 3 times 5. In order to take something out, I need a pair. So here I have a pair of 2's. I can cancel it out, and then I'm going to put 1, 2 on the outside. So now all that's left on the inside is 2, 3, and 5. So I multiply them, I get 30. This is the simplest form of the expression. 40, same thing. Let's factor it. If I put everything, I have 2 times 2 times 2 times 5. Here's my pair of 2's. I put 1, 2 on the outside. And what do I have left on the inside? 2 times 5, which is 10. Sometimes I have variables, I can do the same thing. So let's start. I have 125. I want to factor that. And I'm doing this fast because you know the process. And you can pause if you need to think about it. So 125 is 5 times 5 times 5, and I have an n. I have a pair of 5's. I'll put 1 5 on the outside, and then I have 5 times n left on the inside. This one I have a few more variables, so let's see. 28 is 2 times 14. 14 is 2 times 7. So I have 2 times 2 times 7. I have 3 x's. I'm going to expand a y, then 1, 2, 3, 4, 5, 6, 7, 8 z's. Here's a pair of 2's, here's a pair of x's. I have 4 pairs of z. So I can put 1, 2 on the outside, 1 x, and then 1, 2, 3, 4 z's. And then on the inside, I have an x and y left. This can be condensed. I can write that as 2x, z to the 4, square root of xy. There's my simplified expression. Another one, I already have a 5 on the outside. This is 5 times this whole thing, so let's simplify. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. If you struggle to see that, pause the video, think about it, okay? We can write everything we have on the inside. 2 times 2 times 2 times 2 times 2. Have A times A, and then B times B times B times B times B times B times B. So many B's. Let's identify our pairs. Here's a pair of 2's, here's a pair of 2's, pair of A's, pair of B's. Let's take care of each pair one at a time. I'll put the 5 since it's already on the outside. Here we have a 2. We can put another 2. We can put an A, a B, another B, another B. And on the inside, what do we have left? We have a 2 and a B, so 2 times B. And we can rewrite this whole thing as 20 a b to the third. Notice I have 3 b's. Square root of 2b. Here we have a cube root. Notice the little 3 on top of the root. Let's expand. 8. Don't forget to write this 3 on top of the root. That's really important so people know it's a cube root. 2 times 2 times 2. I times I times I times I. I have to write 9 j's now, guys. Ooh. Now instead of pairs, it's a cube root. So I need to identify groups of 3. There's 3 2s. I'm just going to circle them for you. Let's go one by one. I'll put 1 2 on the outside, 1 I on the outside, a J, another J, another J. There's a K. And what I have left is the cube root of, looks like there's only one tiny I by itself. 2I times J times J times J, I write as 2I J to the third, and then the cube root of I. I have one more. If we have a cube root and there's a negative, the cube root of a -1 is -1, so I'm just going to put a negative on the outside right away. That's something you can always do. And that way we take care of the negative. Now I have 16. Let me factor it. This is 2 times 2 times 2 times 2 times I. And then I have J 7 times. You guys should be pros now. Here's 3 2s. I'll circle that. 3 J's, another 3 J's. With the negative, I can put a 2. I can put a J, and I can put another J. And all I have left under that cube root is a 2, an I, and a J. And now 2 J's, I can write that as J squared. And I have 2IJ. There is my final expression.